In this presentation, we're going to treat a vector in R as a set of data and then use various built-in R functions to do basic statistical measures on that data set. Eventually, we will learn how to read in data from an external data file. But for now, we're just going to copy the data in. So this line of text can be copied from the presentation and pasted into your R program when you're ready. So as often happens when you open RSTUDIO, there may be some previous script open, there may be some data over the environment variables, there may be just some introductory blah 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 in the console, and you may want to sort of do some clearing out. So to close an open script that you do not want, then just click on the little X on the tab for that script. We can clear out the environment region by clicking on the little BROOM icon to sweep it clean. But let's suppose we wanted to clear out some but not all of the things. Then we could switch from list view to grid view using the little drop-down list seen at the top of the environment region. And then that will allow us to choose which values we want to keep and which ones we want to throw away. So you see when we've switched to grid view that the variables now have checkboxes next to them, so we can choose which ones we want to clear out. Now I have checked them all and I'm going to clear them all out, but I wanted to show you that you can clear all or clear selectively. To start a new script, go on the menu to File, New File, and choose R script. I like to save my scripts right away so they have a name and I know where they're located. So I go to File, Save. You can also use Save As, and then find a location for your script and give it a name. Typically we'll have the extension .r so that the computer will recognize it as an R script. Recall you can use Control-L to clear out the console, and now we're ready to start our script. So we're going to copy this vector data from this presentation and then paste over into our script. You can use right-click functions, or you can also use keyboard shortcuts. The standard keyboard shortcut for copying is Control-C, copying whatever was highlighted. And the standard keyboard shortcut for pasting is Control-V, and then you can run that one line of code by highlighting it and clicking the run icon at the top. So we have run our one line of code, and you can see the vector of weather data down in the console, and you can see the vector of weather data in the environment. The tab is in red, indicating that this script has not been saved, and so we can click on the floppy disk icon in light blue to save the script. Now that we've entered the set of data in line 1, we are ready to use some of the R-provided statistical functions to find measures of this data set. So the first one we will do will be the average. R calls that function mean. So in line 6 we see an assignment statement. I've made a variable called AVE and I'm assigning it. I'm using the sort of arrow notation for assigning here, the sort of less than dash. Functioning as an arrow means I'm assigning something to the average variable. I'm using the function mean, and I have open parentheses. Functions always have parentheses, and then the argument of that function is this high_temps vector that I've made, and that calculates the average, and then on line 7 I repeated the word average, so that is going to sort of print it out in the console. So line 6 calculates it, and line 7 sort of, as we say, echoes it out. We'll show it in the console. Another measure of centrality is the median, and R has a built-in median function. So here I am assigning to a variable I called middle the result of the median function acting on the data. So in line 12, middle Then I'm using the less than dash, the arrow notation for assigning, using the function median. In the parentheses, I have my vector high_temps. And then I'm also on line 13, repeating the word middle so that the median result is echoed out down in the console. To get a measure of the spread of the data, we can calculate its standard deviation. R calls this function SD. So I am creating a variable I called stdev. I'm using the arrow notation to assign it. I am using the built-in function SD, open parentheses, and then the argument is the high_temps vector, and I'm repeating stdev so that the result displays in the console. Here I am showing the min function, which gives us the minimum of the data. And likewise, the max function will give us the maximum, so I've made a variable called most, and I've assigned it the output of the max function acting on the high_temps vector. So we've already seen the median, which is a measure of centrality. And this is obtained by putting the data in order, what we call sorting it, and then finding the midpoint, the sort of 50% of the way. The first quartile is similar, that you sort the data, but now you take sort of 25% along the way. And there's also a third quartile, which is 75% along the way. And these combined quartile arrangements give you an idea of spread. R has a built-in function for this called QUANTILE. It's rather like Excel's percentile, but it's very similar in spelling to Excel's quartile. So make sure you get quantile and quartile straight. The R belongs to Excel, the N belongs to R. So here I am in line 35 using the quantile function to get the first quartile. Okay, so I've created a variable called first_quartile. I'm using the arrow notation to assign. I'm using the built-in RSTUDIO function quantile, and it takes two arguments. The first is the set of data, high_temps, and the second one is a 0.25, representing that we want it 25% of the way through the data. And so here we are getting the third quartile just by using the second argument of 0.75. I can get a whole set of statistical measures of the data by using the built-in R statistical function called summary. So here I'm assigning to high_temps_summary the output of the summary function acting on the high temps vector, and it gives me the minimum, the first quartile, the median, the mean, the third quartile, and the maximum. So a nice handful of statistical measures for the price of one function, the summary function. Now we mentioned sorting the data, putting it in order when we talked about what we meant by the median and the first quartile and the third quartile. But getting those functions doesn't sort the data, it just sort of behind the scenes sorts the data and grabs what you want. But if you actually want to sort the data, there's a function for that, sort. So here I'm using the function sort acting on the high temperature data and then assigning that to sorted_high_temp. So that is a new vector now in which the temperatures are listed from the lowest temperature to the highest temperature. And now that the temperature is sorted, we can do things like we did in Excel. We can grab the second smallest or the second largest or something like that by finding the position in the new sorted vector. So I can say the sorted_high_temp square bracket 2. That is going to give me the second temperature in the list. And then I assign that to something I called second smallest and echoed that out. Now I want to point out one thing here. Using the square bracket 2 is grabbing one, what we call an element from the vector, just one of the components. And most programming languages would start at 0, but R is unusual, and then it starts at 1. So the second smallest temperature has an index of 2. Next, I want to work my way towards getting the second highest, but in order to do that, I need to know how many data points there were. And so here I'm using the built-in function length, which is going to tell me how many data points were in my vector. So in line 65 there, I say sample underscore size. That's a variable I made up. I've switched over to the equal notation for assignment, and then I'm using the built-in R function length, and it's acting on the vector. My argument is the vector of high temps. So because our indices start at 1, then when we sort, the temperatures start from the lowest temperature to the highest temperature. If I put in what I called sample size, for the index, that would get me the highest temperature now that they're sorted. But if I want the second highest, I'm going to put in as the index sample size minus 1. I point out here, of course, that sample size was 31. That was how many days were in that month that we were considering. But we wanted to do it more generically to be able to use this for any set of data of any size. So again, the array index, sample size minus 1, is the sort of next to the last in the sorted list, so that makes it the second highest. We can make a fast histogram of the data by using the built-in R function hist and using as its argument our vector high underscore temps. Now, we can get more control later on by adding additional arguments, but for now we'll just take the sort of default values that it chooses for us automatically. Now the histogram is produced in the region on the right beneath the environment region, which has a number of possible tabs, but when we make a plot, it will sort of automatically bring to the forefront the plot tab and display the histogram there. We can similarly use the built-in function BOXPLOT with an argument of high underscore temps, made a box and whiskers plot of our high temperature data, and again displayed it in the plot region under the environment next to the console. Using BOXPLOT.STATS, open parentheses, high underscore temps, it gives us the data used in making the box and whiskers plot. Now the previous data had no outliers, and I wanted to see what an outlier would look like. So I went to the original set of data and changed the first temperature to 100, highlighted the entire script and ran it. And now you can see in the plot the little circle indicating the outlier of 100 is not part of the box plot, but is sort of outside of the box plot. And then down over in the console where I'm showing the BOXPLOT.STATS, you can see that the temperature of 100 is listed under $out, so it's identifying it as an outlier.